Hi, okay, so for number 3, what we're going to do is we've got this equation here. Oh, didn't have my pen on. We've got this equation and it's graphed right here. So I'm going to take that equation and then I'm going to find the derivative and then fill in this table right here. And then once I've done that, I'm going to take my table and graph it right here. That's the plan. Let's give it a shot. Okay, if this is my function right here, then the derivative would be 2x minus 4. So I'll write this over here just so I don't forget it. 2x minus 4. And then, let's see. So if I plug in negative 4 into my table, I would get negative 8 minus 4 would be negative 12. And then if I plug in negative 3, I get negative 6 minus 4, that's negative 10. And then I'll do one more, and then I think I could figure out the pattern. 2 times negative 2 is negative 4, minus 4 is negative 8. So it looks like it's going down. Well, actually, it's going up. It's just they're negative, so it's a little confusing by 2's. So I'll just keep going with that. And then I'll check here. So if I plug in 2, 2 times 2 is 4, minus 4 is 0, so that checks out. Whew, I just ran up and down the stairs. My son is watching TV upstairs, and it's very loud. Okay, so one more time I'm going to check just because I think the pattern makes sense. I should still check. So if I plug in 10, 2 times 10 is 20, minus 4 is 16. Okay, perfect. So this is like a table of values for my derivative, and I'll use that to graph my derivative. I could also have taken this equation right here and said, okay, there's a b-intercept at negative 4, a y-intercept at negative 4, and then graphed it that way. But I kind of wanted to get the idea that this derivative, it gives you the slope at each point. So I don't know if I did that, but that was my goal. So let's see, at negative 4, it's negative 12. And then I'll pick another one. 3, it's 2. And then at 9, it's 14. Okay, so it's not great, but that was actually not my worst line. And I just want to make sure the x-intercept makes sense. So at 2, it should be 0. So it wasn't perfect, but it's pretty close. So the thing that I wanted to point out is, so this top thing, this is the original. And this one down here is the derivative. So imagine for a second that we didn't know anything except these two graphs. This is the only things we knew. And then now I want to try to make a connection between the two. So a thing that I notice is that this down here, this is my minimum. So on my original function, the minimum is at 2. And on my derivative, what's happening at 2 is there's an x-intercept. So this is like a thing to think of. If the original function has a minimum, then the derivative should have an x-intercept in the same spot. Then another thing to think about is, think of all these slopes here. The slopes are negative on the left before the minimum, and then they're positive after the minimum. And the way we can see that on the derivative is all of these slopes, right? These values are slopes, are negative. All these values are slopes of the original function. They're all negative until the x-intercept, and then they become positive again. Okay, so I'm going to clean that up because it's, oh, that was harder than I thought. There we go. Draw my line back in. Okay, so now that we've kind of gotten the idea of what the point I'm trying to make, I thought we could fill in this table down here. The original graph is increasing over which intervals? Where do you see this? Oops. In the graph of the original. Okay, so we talked about after the minimum, so from 2 to infinity, it's increasing. And we can see that in the graph of the original because these slopes are positive. So let's put this in. Y is increasing over the interval from 2 to infinity. because it has positive slope there, this means that the graph of the derivative has positive y values over the same interval, right? So from 2 to infinity up here, all these values have positive slopes. And then in the derivative, all of the y values are positive. Okay, the original graph is decreasing over which intervals? Okay, we know that now is negative infinity to 2. Where do you see this? I copied and pasted. In the graph of the original. Okay, so you can see that it's decreasing from negative infinity to negative 2 because all of these tangent lines have negative slopes. That was really poorly drawn, but hopefully you get the idea. And then we can see this in the derivative because all of these have negative y values. Negative y values. Okay, part C says, where do you see the minimum of y in the graph of the derivative? Well, we just talked about this. It's at the x-intercept because it changed from negative slopes to positive slopes, or negative y values to positive y values at the derivative. Okay, so how can I word this? Where do you see the minimum of y in the graph of the derivative? Okay, it is at the x-intercept. And the y values change from negative to positive at that intercept. Cool. Well, let's pause there and we'll do the next one.